Okay, so today the things you got to know. Okay, in order for you to find a couple things, the domain, you can just set whatever is under the radical, which is this thing right here. Uh, oh wait, I need to put it. Sorry. Sorry, I forgot to. Oh, that's what I forgot to do. I need to give it to. Not to import open. Okay, there we go. Okay. To find the domain, all you have to do is set this equal to greater than equal to 0. That will give you the domain. The range is whatever is outside the radical. So this K is the range. And then you can find the minimum point of any radical by finding the domain and range. So in this case, H and K. So pretty easy. Here's an example. So you have g of x is equal to the square root x minus 2 plus 4. To find the domain, all you have to do is set this part right here, x minus 2 greater than or equal to 0. Add 2 to both sides. X is greater than or equal to positive 2. And you can see I have found the domain. The range is whatever is outside the radical, so the plus 4. So you can just put y greater than or equal to 4. So you don't actually have to write an equation for the range. It's whatever is on the outside. And then after finding the domain and range, positive 2, positive 4, it can actually give you the minimum points of the equation. And that will help you to determine the graph. Okay, so here's the graph. The domain, which is positive 4, means you're going to go up 4 units from the original radical equation, and then the horizontal, you're going to go to the right 2 units. So when you graph this, there's 2 ways to graphing it, either using a table or using translation. And honestly, translation is honestly the easiest form of graphing these. So when it's x minus 2, this means, let me find my thing. So right here, using translations, so the x minus 2, this means you're going to go to the right 2, and then the positive 4 means you're going to go up 4. When you're graphing any type of equation, you'll need 3 coordinates. So this one right here, the square root of x, there's 3 coordinates you need to know. You need to know 0, 0, 1, comma 1, and then 4, 2. Those 3 coordinates gives you the original equation. If you do the transformation going to the left to up 4, you actually get the graph. So here, 1, 2, 1, 2, 3, 4, put a dot. Do the same thing for this one. Oops. 1, let me make it smaller. We can make it smaller. Nope. Go 1, 2, 1, 2, 3, 4, put a dot, and then you'll end up right here. Same thing for this one. 1, 2, 1, 2, 3, 4, put a dot. And then you get the new graph, which is this right here. So that's what we're going to be practicing today. We're going to practice how to graph it and then find a couple things from the main range. All right, let's get to number 1, which is in the back of the paper. It says, for the given function, determine the domain of the function. So that's part A. So remember, to find the domain, I take whatever's inside the radical. So this thing right here, greater than equal to 0, solve for x. X is greater than or equal to +5. That is my domain. Now, this is inequality notation. Inequality. The homework will either tell you inequality notation or interval notation. And the way you write this in interval notation is you're going to have bracket 5 to infinity. So there's two answers to write the domain. Either write it in inequality notation or interval notation, where you have to use a bracket, +5, comma, infinity. For part B, it's gonna tell you to write it. You're gonna have to create a table to plot, to graph the function. So in this case, we have x comma y. Now, your very first point is gonna be the minimum. Okay. If there is no number on the outside, what placeholder can we put outside? Not 1. Because if you put 1, it's gonna change the whole function. What placeholder can we put? 0, exactly. Because that placeholder is going to help me to determine the minimal point. So my minimum x coordinate is 5, not -5. So you have to be very careful. It's not -5. It's +5. And then my y coordinate is whatever is on the outside. In this case, we use the placeholder for 0. And then we're just going to plug in points. So 6, 7, we'll go up to 8. Right? Because x has to be greater than or equal to 5. So every number greater than 5. So we're going to do 6, 7, and 8. So we're just going to plug that in and solve. 6 minus 5, 7 minus 5, 8 minus 5. And we got to figure out what those are. So square root of 6 minus 5 is square root of 1, which is just 1. Square root of 7 minus 5, which is 2. That is 1.41. 8 minus 5 is 3. And the square root of 3 is 1.73. After we have our coordinates, all we're going to do is going to plot. Does everyone have this down first? Does anyone have any questions? Is anyone confused? Yes, Nora. That's 1. That's a 1. It's a it's a 1. Okay, so we're gonna plot it 5, 0, which is right here. 6, 1, and then we're gonna do the best for 7 and 8. So 1.48, which is right here, and then 8 is 1.73. And then all you have to do is just draw a line, and you have the graph. And then 5, 0 is the minimum point. Does anyone have any questions so far? Okay. Part C It's asking you to, based on the graph, determine the range of the function. The range meaning your y, right? Because that's your y. What happens to our graph as it increases? It increases from what coordinate? What y coordinate? No. It increases from 0, right? The y coordinate here is 0, and it's going to keep increasing. If you look at the table, you see you start at 0, you go to 1, you go to 1.48, 1.73. So that means, according to the table, it keeps increasing. But the lowest coordinate you can have for the y coordinate is 0. So that means it's y greater than or equal to 0, which technically you didn't even need the graph or the table. You could have just looked at the placeholder and seen that this is plus 0. So that means my range is everything greater than or equal to my k, or in this case, 0. So that's inequality notation, and then interval notation is 0, positive, infinity, parentheses. Yes, Liam.
For interval notation, is it supposed to be one bracket, one parentheses, or brackets?
Repeat what you just said again.
Is it both brackets?
No, only the one with the 0 is a bracket. The other one's a parentheses. This is a parentheses. This one's a bracket. Yeah, the top one's also a bracket and then parentheses. This is a bracket, and then this one's a parentheses. So good question, very good question. Does anyone have any questions so far? Yes, question.
Why do you use one bracket, one parentheses?
Because the bracket tells me that my answer can be 0. My parentheses tells me that I'm just going to keep going on to infinity, but never reach infinity because it keeps going on forever. So that's the difference between bracket and parentheses. The bracket just tells me that my range can be equal to y and anything greater than equal to that number. So, okay, let's move on to number 2 and 3. It says find the domain and range. For the square root function, state the x and y intercepts if they exist. The x and y intercept is going to be a little bit tricky, but we'll do the domain. So part 1, the domain, pretty easy. Just take whatever's under the radical and put it greater than or equal to 0. Solve for x, -16. So that's my domain. That's an interval notation. Sorry, no, that's inequality notation. Interval is bracket -16 to positive infinity. You're only going to have to use one. Just make sure you read what it's asking you, because it can ask for either one. It's not going to ask you for both. So that's the domain. The range, it's pretty easy. It's y greater than or equal to whatever the number's in the back. In this case, it's just -7. If there is no number, you can put the placeholder of 0, so that way you don't forget that it's 0, because you can't just say it's nothing, because there is something, but it's a imaginary. Oh, and then that's a inequality, so then put in interval notation. Okay, the next ones are probably the hardest part. X-intercept. This is when y is equal to 0. So you're gonna have to plug in 0 for y and solve for the equation. So 0 is equal to square root of x plus 16 minus 7. So solve, add 7 to both sides. 7 is equal to the square root of x plus 16. Does anyone know how you get rid of a radical, the square root? What do you have to do? Does anyone remember from last year? How do you get rid of a radical with the square root? You square both sides. Squaring both sides will get rid of the radical. So on the right-hand side, you're just left with x plus 16. And then the right-hand side, you actually have to square it, which will give you 49. And then just solve for x, minus 16, minus 16. X is equal to 49 minus 16, which is 33. So x equals 33 is your x-intercept. Now you can either write, it might ask you to write it as x equals 33, or it might actually just ask you to write it as a coordinate. So 33 comma 0. Any questions so far? Okay, so that's the x-coordinate, sorry, x-intercept. The next one is the y-intercept. And this is when x is equal to 0. Then you're just going to write the equation. Y is equal to the square root of 0 plus 16 minus 7. Honestly, the y-intercept is probably the easiest because it doesn't require as much work as the x-intercept. So 0 plus 16 is just 16. The square root of 16, if you plug that into the calculator, you'll get 4. 4 minus 7, negative 3. So you can either plug in y equals negative 3 or the coordinate 0, negative 3. That's your y-intercept. And then this is your x-intercept. Does anyone have any questions? Now, the reason why I asked you if it exists, because the y-intercept might not always exist. If you have a problem like this, where you have to be careful, y is equal to the square root of x minus 2. If you have something like this and you want to find the y-intercept, where x equals 0, we have y equals 0 minus 2. 0 minus 2 is just negative 2. You cannot take the radical of a negative number. This does not exist. Even if you plug this into the calculator, it will give you an error. So you have to be careful when you're finding the y-intercept because it doesn't exist if you have a negative under the radical. So this case, the y-intercept, spell it correctly, does not exist. So do be careful if this pops up either on your homework or if you try to do the extra credit, and it asks you to find the y-intercept for a radical with a negative number. All right, does anyone have any questions so far? Now, the reason why I asked you to find the x and y-intercept is because you can actually use the coordinates to help you graph, but you don't necessarily need them. But it is helpful to know how to find them if you're ever trying to graph. All right, so next page behind says make a table of values and graph the function. We are not going to do that. We are going to do the short and easy way of just doing translations. And then we're going to find the translation by just stating the domain and range. So, because it just makes it helpful. So the domain, x plus 5 greater than equal to 0, solve for x. x greater than or equal to -5. My range is y is greater than or equal to +3, right? Because it's just this number outside. And then my domain is whatever is inside the radical, it's set equal to 0, which gives me the minimum point. -5, 3. You want to use these values right here. So that'll give you your minimum. Does anyone have any questions so far? So that's it. Okay. So here's how to do it the easiest and most accurate way. So for a radical, remember we said that you start with 0, 0, 1, 1, and 4, 2, right? This is the original graph for a radical, square root of x. Now, I'm going to do translation. The x plus 5 in the radical means I'm going to go to the left 5, and then that +3 means I'm going to go up 3. Inside the radical, you have to do the opposite because it's +5, you're going to go to the left. Usually students get confused that since it's positive, you go to the right. It's incorrect. It's kind of in reverse order. So x plus 5 really means to the left 5. So then I'm going to take this point, count 1, 2, 3, 4, 5, and then go up 3, 1, 2, 3. Put a dot right there. Then I'm gonna take this one right here, same thing, 1, 2, 3, 4, 5. Go up 3, 1, 2, 3. Put a dot. Then this one, 1, 2, 3, 4, 5. 1, 2, 3. Put a dot. And if you did it correctly, you should get a graph that looks something like this. That would be your graph for the square root of x plus 5 plus 3. And as you can see, your minimum point, -5, 3, should match the minimum point that you got when you did the domain and range. Yes. This one? This one right here? It gives it to you in the very beginning. The one in blue. Yeah, that's the original one. Does that make sense? All right, and that is it for number 4. We'll do one more with number 5, and then one more with number 6. So graph the function, write the domain and range as inequality. So in this case, it's going to want it as inequalities. So we're going to start with domain. X plus 4. When you get used to it, you'll know that this would just be what? Without actually having to write the equation. X is greater than or equal to -4. And then the range is whatever it's on the outside. So y is greater than or equal to -5. So think of it this way. If it's inside the radical, think of it as opposite. If it's positive, it becomes negative. If it's negative, it becomes positive. But it's only when it's inside the radical. So now we're going to use translations. So we're going to write t. That positive 4 means I'm going to go to the left 4. And that negative 5 means I'm going to go down 5. So we're going to do our original coordinates. 0, 0, 1, 1, and then 4, 2. This is the original graph. And then I'm going to take every coordinate and just do whatever the translation told me to. Left 4, down 5. So 1, 2, 3, 4. 1, 2, 3, 4, 5, which is right here. And then I'm going to erase it so that way I don't get confused. Then with the next one, same thing. 1, 2, 3, 4. 1, 2, 3, 4, 5. With the other one, 1, 2, 3, 4. 1, 2, 3, 4, 5. Put a dot. And then this is my equation. This is my graph for y is equal to the square root of x plus 4 minus 5. And then you can erase this one, but I just like to keep it because that's my original graph. And then this is my new graph for my equation. Does anyone have any questions? All right, last practice and then done. Okay, graph the function, the square root of x minus 9. Always put the placeholder if you don't have one. Same thing, if you get something like this, y is equal to the square root of x plus 3, you can put the placeholder inside the radical as well. So always putting the placeholder sometimes makes it easier. Okay, in this case, this one doesn't ask us for the domain and range. So the only thing we really need is just the translation rule. Okay, what does the x minus 9 tell me? How am I going to move my function? My graph, sorry. So what does the x minus 9 tell me? Where am I moving it? Yes, Luke.
To the left, 9.
You're kind of close. It is going to left and right, but it's not going to go to the left. Right, 9. When it's inside, you got to think of it being opposite. Now, am I going up or down? No, because it's 0. So you do not go up or down. So no up or down. So all you're doing is just going to the right 9. So plot 0, 0, 1, 1, 4, 2. So I'm going to take each of those points and then move them to the right 9. Right 9 or left 9? Yeah, right 9. So let me color code it. So right 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Put a dot. One, 2, 3, 4, 5, 6, 7, 8, 9. Put a dot. I'm gonna have to go to the, so 9, 11, 12, 13. I think that should be enough. 1, 2, 3, 4, 5, 6, 7, 8, 9. Put a dot there. And then my graph will look something like that. Y equals the square root of x minus 9. And this one right here is just y is equal to the square root of x. So that is my original function. Does anyone have any questions? This homework is kind of lengthy because I do want you to practice as much as possible to either find the domain range, minimum point, or just the graph. Other than that, that's pretty much today's lesson.